What planet does this look like? I'm thinking Saturn. I really am. But do you remember that all of the, and I'm going to go over here, all of the gas giants actually have rings, okay? So that's a little tricky. This actually, you don't have this slide. These are kind of a couple of tables and a picture, a figure that we talked about clear back when we talked about the formation of our solar system. Remember how that worked? The solar nebula, okay? Solar nebula should go like this, right? Solar nebula, this is the sun. And of course, close to the sun, it was the warmest, okay? And you guys told me that, like, for instance, water might be liquid here or gas here, but if I go far enough away on the other side of the frost line, water can be ice. And so that's actually kind of a player in the formation of these gas giants. Water could actually go ahead and solidify. Okay? Here, the only thing you could get to solidify were the metals and stuff like that. So that's kind of, remember we have the frost line. What planets is the frost line between? What do you think? What's here for the frost line? Saturn. Jupiter is on the other side of the frost line. What's on the inside of the frost line? Hey, our outermost terrestrial planet. Mars. Yep, we have Mars, asteroid belt, and then we have Jupiter. Frost line's kind of where the asteroid belt is, basically. Okay, so now you do have this slide, right? So as we're talking about the gas giants have, oh my gosh, is there just two names? The gas giants, the word Jovian oftentimes is used for Jupiter, Saturn, Uranus, and Neptune. And I kind of think of them going in pairs. Jupiter and Saturn have that kind of pretty orangish sort of color, okay? And Uranus and Neptune have kind of that blue color. But what they all have in common is they all have rings. Another thing they all have in common is they all have moons, a series of moons. Another thing they have in common is you can't stand on them, okay, because the surface is gaseous. But I think I mentioned the other day, if you fall far enough in and survive the trip, you're going to hit kind of a pit, you know, like how peaches have pits. Kind of these gas giants have pits. It's like they swallowed a terrestrial planet. I think that's kind of weird. I mean, they didn't really swallow it, but kind of the stuff sank. Okay. So down here we kind of have some good, I like this figure from your textbook. You have some good information. So these kind of look alike because they have similar composition. So what does H stand for? Hydrogen. And HE? Helium. So I have hydrogen, helium, hydrogen, helium. Okay, actually these have, then we kind of have hydrogen, helium, hydrogen compounds. So what does AU stand for, you guys told me? Astronomical units. So the Jupiter is about 5 times the distance from the Earth, okay, to the Sun. Okay, so 5 AUs. But about 10 AUs for Saturn, okay, about 20 AUs for Uranus, and about 30 AUs, that's out there. Okay, no wonder it's blue, it's so cold. No, I'm just kidding. So
at the center of the gas giants is a rocky.
Yeah. So each of them kind of have a rocky pit, and it's because of pressure. It's not because of temperature, because they are warm in the center. It's because of pressure.
So it's almost like a really big atmosphere.
Yeah, it does get kind of tricky because we're going to talk about the clouds, and then kind of beyond the clouds, then you start the gas giant. So it's like, well, what's the difference between clouds and the gas giant? But I guess there is a subtle difference. Yeah. So in physical science or just in life, we're all about density. So if I have styrofoam here, would you say that's very dense? It's pretty light. Okay, and if I had a rock here, you'd say that's pretty heavy. I could have the same kind of volume, like a handful of styrofoam and a handful of rock, and this one way more. Okay, similar volumes, but this is more dense. It weighs more. So density, actually, I'm excited because density is a player in making one of those exotic things we know as black holes. Okay, so the thing about black holes is basically you have gotten something, could have been styrofoam, you squish it down, make it more and more dense, you squish it down. And with a black hole, basically, you squished it down to the point that those atoms that made up that you could do styrofoam. You could make styrofoam in a black hole. Okay, But basically, to make a black hole, that material now, the atoms, how do I say this? The atoms are kind of coexisting at the same place. Okay, so that's a problem. But anyway, so density is an issue. Do you guys remember which planet would float on water? Do you remember which one? It's one of the gas giants. Yeah, Saturn. It is Saturn would float on water. Because Saturn actually is less dense than water. So I think that's kind of cool. I do. I think so. So here's to say, how do I say this? So if I'm right, I am on the other side of the frost line. I am the first gaseous planet. I am, starts letter J, Jupiter. I am Jupiter, yes. And Jupiter, as it turns out, actually has the most mass of all the gas giants. And because it has a lot of mass, it's not to the point of making a black hole in its center, but because it has a lot of mass, kind of like these pillows, it kind of squished down, okay? So Jupiter, kind of drawn to scale, if you look back at the previous slide, Jupiter and what's the next planet? What's the start letter S? Saturn, yeah. They kind of have similar volumes. They're similar volumes, okay, but Jupiter is squished down a little more, kind of like these pillows a little bit. You know, pillows are fluffy, but by golly, if you get enough pillows, they're going to start squishing down. So Jupiter is more dense just because it's got more stuff, kind of. And gravity, just like gravity on Earth, gravity on Jupiter kind of squishes the stuff down. Okay, so here we go. Here's one for you. Like if you get that spray can compressed air, you know, like if your keyboard, if you need to blow off your keyboard, you go to the store and you buy compressed air. If you ever kind of shake it before and can kind of hear the liquid there, it gets cold too, yeah. But basically, if you hear the liquid in that can, what they did to make that air is they compressed it. And it's liquid. You could take anything that's a gas and you can squish it together, and actually it will turn from a gas to, it will join bonds, shake hands, the molecules will shake hands and go from gas to being a liquid. Okay? And so we actually kind of have that phenomenon going on in, well, everywhere, but kind of in these planets out here. We have layers of liquid. Check this out. Okay, gaseous hydrogen, liquid hydrogen. Are you serious? You can really take hydrogen and liquefy it? That's a hard thing, but it has to do with the pressures. We have metallic hydrogen, which is kind of a strange sort of cat that hydrogen can do. And then down here, okay, this, I don't know if you can read the caption, it says core of rock, metals, and hydrogen compounds. So that thing down there, that's like the terrestrial planet in the center.
This is on Jupiter?
This is a cross-section of Jupiter. Yeah, this is a cross-section of Jupiter. And kind of like, do you remember when we did kind of the planets, we compared kind of we have the planet core, the planet mantle, and the planet crust. Kind of similarly, what your author's done is this is Jupiter, this is Saturn, kind of from left to right. And that blue thing is kind of the terrestrial planet it swallowed. And then the kind of purplish color is the metallic hydrogen, liquid hydrogen, gaseous hydrogen.
What is metallic hydrogen?
Metallic hydrogen, we don't have enough time to talk about it. I'll post a link. I'll post a link. But here on Earth, we don't have conditions on a routine basis that we can have hydrogen behave like that. But they do. Uranus and Neptune, what would you say about their volumes compared, these blue guys, compared to, you think they're smaller? They're definitely smaller. They have a little bit of different composition. This actually points out that, see, spacecraft that NASA sends out, or actually ESA stands for, anybody know what ESA stands for? European Space Agency, yeah. ESA is like Europeans' version of NASA. So they send something out to kind of study a planet. Well, they have some options. They can orbit that planet, okay? They can land on that planet. They can't land on a gas giant. But in this case, the spacecraft Galileo in 1995 gave its life. I just think that is so. It like fell through the Jupiter's clouds and sent back a bunch of good information. So thank you, Galileo. You know, it's like true. Okay.
Do you know how far it got in before it stopped?
I'm sure they do know how far it got in before it stops, yeah. But a lot of the science that we know about the planet kind of came from spacecraft like Galileo.
Why did they name it Galileo?
Why did they name it Galileo? Probably because like the Galileo, the scientist that studied Jupiter, Galileo actually saw that, we're going to see Galilean moons. Galileo actually saw moons orbiting the planet. So probably to honor him. And Galileo, remember in 1995, 92, finally the Catholic Church recognized his work. Yeah, Galileo. Remember that was, yeah. So I pushed this one out there. All right. Did you guys see the slide where Jupiter has one of these? Is it very big?
Yeah.
Yes, it is very big. We talked about northern lights, and I'll just go ahead and kind of remind you how northern lights work, aurora borealis. Basically, northern lights happen because the sun sent solar wind, charged particles from the sun. Basically, there's too many of them, and it's called what is that called? The donut-shaped things, named after Dr. Van Allen. Yep, the Van Allen belts, okay, actually overload with charged particles, and they come down to the polar regions. And they create our northern lights. So actually, did you guys see kind of, I think it was Jupiter kind of showed kind of a flashing up there at the poles? Okay, that's like our northern lights, but for Jupiter. Okay, I thought that was kind of neat. Okay. Get 4 Galilean moons, the closest Galilean moons, 2 letters, Io. Io. Okay? So actually, Io is the closest, and it's kind of shown.
Does the sun have a magnetic field too?
The sun, yes. The sun is kind of weird, and we'll talk about the sun's magnetic field. It doesn't have a magnetic field like this. The sun basically has like mini magnetic fields kind of coming out of its hot spots, its sunspots, and kind of going in.
Is this like chaotic kind of?
Yeah, it's kind of chaotic. The sun's magnetic field. Yes.
So do you need to know all the moons of all the planets? Like the name?
Look at your review sheet. Yeah. So, no, but you need to know a few of them. You need to know the Galilean moons. Yeah. Galilean moons around Jupiter. Okay. So there's a whole, I don't know if I guess it is a science, special niche of planetary science that talks about what's the weather like on the other planets. So we talked about it's kind of hard to kind of say where the Jupiter's atmosphere ends and where kind of the gaseous planet starts. I grant you that's hard. Actually, right here is kind of a cross section of, you can kind of see the tan, the kind of the orange, and the kind of white down there. Each of those colors are things that you might see in Jupiter and Saturn's atmosphere, and they actually represent different compounds. Compounds to me are really exciting because compounds are where atoms have joined together, like water is a compound. You know, methane is a compound. Here we've got ammonia is a compound, NH3, ammonium sulfide, okay, and actually down here there's water. So kind of when you see those kind of cool swirls in Jupiter, and actually Saturn has some kind of pretty banding too. Think of all those different kind of compounds in their clouds. Okay, 2 blue planets. What are the blue planets?
Neptune and Uranus.
Yep, Neptune and Uranus, exactly. Anybody know the chemical formula for methane? Cows. It is CH4, very good. And there's going to be a test question probably, why are the blue planets blue? And the answer is because of methane, basically. Very good. Let's see. Great red spot. Oh yeah, oh yeah. Great red spot is associated with which gaseous planet? Jupiter. So that might be one of your test questions. So your test questions, some are harder, some are easy. Great red spots associated with Jupiter. And actually, it's not a static sort of circle. If you were to look at it like an animated, like a video of the great red spot, it would kind of go, it would kind of twirl a little bit, and it would, it's like a hurricane.
Yeah.
Yeah. If you study weather, they'll talk about why hurricanes do what they do, and it has that spin actually is caused by the Earth's rotation, called Coriolis effect, or Coriolis force. And so that's actually what gives spins to some of the cool things we see in Jupiter's clouds. I think this is cool. Can you see these arrows here in this middle one? They're alternating, goes this way, That's actually kind of, and kind of centered on the equator. That's how the clouds in Jupiter moves. Like this cloud will move this way, this cloud will move this way. And they're called belts and zones, and I can never remember which is which. So the darker ones are belts and the whiter ones are zones. And actually the color is a way, I think the white ones are rising and the dark ones are sinking, I'm not sure. Something like that. I think that is so cool. Jupiter's beautiful. Okay. So hopefully we're kind of thinking, when you go out to these gas giants, they all have rings, they all have moons, okay?
Do the rings always go around the planet's equator?
Yes, the rings always are centered around the equator, yeah. But what's the deal with the rings for Saturn they talked about? Is it one solid sort of sheet?
No.
Nope, it's like little tiny things. That is so cool. And then over here, did you catch it in the video? This is the dark spot associated with Neptune. Is it still there? Nope. Is the Jupiter's great red spot still there?
Yes.
Those are kind of cool. Now we talk about moons. So actually, I hope you got from the video his excitement about Saturn's got a couple of really interesting moons. Saturn has the moon Titan, and Saturn also has the moon Enceladus. But Jupiter, of course, has the 4 moons that Galileo saw. So up here at the top, these are the 4 moons that Galileo saw. And they're listed in order of closest to Jupiter on out. So there's Io, Europa, Ganymede, and Callisto. Okay. And I've heard different numbers for how many moons there are orbiting these Jovian planets. Because, anyway, this slide says there's more than 60 orbiting Saturn, 170, what was this called? So I had the video, what did he say? I don't know, he threw out a number, how many moons are orbiting, but there's a lot. Was it 63? I think so. Yeah. And the thing about we talked a little bit about this, if they're nice and rounded off, actually that's an indication of their size. If they have enough mass and enough I guess volume, but enough mass, they actually over time will kind of round themselves off. What's that? Kind of like a star, that's right. So what do the moons around Mars look like? Potatoes. They do, yes, potatoes. They're not big enough to have rounded themselves off yet. Okay, so for comparison down there we have Pluto, the moon, and Mercury. Okay, Pluto's pretty small, guys, I'm just saying. Okay, Saturn's medium to large moons. Here's Titan. Titan's the one that has an atmosphere. And I didn't realize it, did you catch that? Because I said we've landed on Titan. But did he say, yeah, he said like the Cassini spacecraft that's still orbiting Saturn actually had a little extra rider and strategically ejected, it's called Huygens, another little spacecraft to land on the land on the moon Titan. Is that not cool or what? Oh my gosh, that's so cool. Anyway, so Enceladus and Titan for Saturn. Uranus, I think the video talked about Miranda. That's the one that kind of looks sort of like it's kind of stitched together. And then Neptune, here's Neptune's ones. Oh, they're there. Okay, Triton. I like the Death Star one. I can't remember. That might have been associated with Saturn. I thought that's kind of cool. So while I'm thinking of it, if you go up to the observatory or even, yeah, through my telescope too, but through a nice telescope that's got a good image of these planets, these gas giants, a lot of times you'll be looking through and you're like, oh, there's Jupiter. And you'll kind of look and there'll be actually some little dots that look like little tiny stars next to Jupiter. Those little dots are actually moons that are orbiting Jupiter. And there's an app for that. There are apps out there, so feel free to check it out. But you can look at an app for Jupiter, and it will tell you where the moons are. So like when you look through your telescope, you're like, oh yeah, well that lines up with this on my app. That is so cool. Okay. So small Jovian moons, they kind of look like Mars moons. Yeah, a little more potato looking. But they're neat just the same. So how many Galilean moons are there?
4.
4. Now that's not a test question, but there are 4 Galilean moons, and you might want to just get them on your note card. Remember, you can take a note card to your test. Okay, the closest one is Io. This is a slide all about Io, and he didn't go into it in much detail, but he showed a picture of kind of a side view of Io erupting, like one of, not the whole planet, not the whole moon erupting, but a little volcano on Io erupting. And he said kind of in passing that the reason Io is volcanically active has to do with tidal forces. Okay, and this is actually kind of talking about tidal forces. Here on Earth, what causes Earth's tides? The moon, very good. And it's kind of the gravitational pull of the moon. So along those lines, actually Io gets, and I want to think of Io, have you ever had one of those like stress balls? And if you're like really stressed out, you squeeze it several times, what happens to the temperature of the stress ball? It gets warmer, it increases, exactly. So that actually is kind of like the flexing that Io feels because of gravity. It flexes, Io flexes. And it's kind of shown here how that works. So here in kind of the gold is Io, okay? Here we have the next one out, Europa, okay, and Ganymede out here. So you figure Io has a kind of a pull due to the planet Jupiter, and then kind of a pull due to the moons that kind of go like that. And so it kind of gets pulled out, and then the moons pass, and it relaxes. Pulled out, the moons pass, and it relaxes. Okay, so that's the tidal flexing. That's just like doing this with your stress ball. Okay? And that actually kind of gives it the thermal energy in its interior to do what it does. What else do we got? Oh, so we have Io, Europa, Ganymede, and Callisto. So these are actually, this is actually an image of the crust. And for the Europa, and I think they think Ganymede and Callisto, they think that if you go underneath the crust, there's liquid water. Yes?
Now when they say water, is it like our water or?
Yes, it is our water. It's the molecule H2O. Now, it's probably salty water, which around here, if we want to keep water from freezing, we put salt on the roads. Actually, salt on the roads makes the freezing point temperature of water less. Or, excuse me, lower. Freezing point temperature of water lower. So if we have this here, if it's kind of chock full of kind of salts and stuff like that, it actually can freeze at a lower temperature. So it stays liquid longer. So anyway, yeah, I think that's kind of cool. Well, that's Europa. And then we have Ganymede and Callisto. They're pretty big. As far as I know, spacecraft have not landed on these Galilean moons. When I think of a moon that's been visited by spacecraft, it's the Titan associated with Saturn. Okay. Speaking of, dun dun dun, there's Titan. So Titan has an atmosphere. It's large enough to have an atmosphere, and I guess the gases were captured, and or just like the terrestrial planets kind of oozed gases out from their interior. Okay. This one, like this over here at the far right, this blue actually is showing you a lake on the moon Titan. But here it's not, because you asked, is it regular water that's underneath like the Europa, the crust of Europa? Yeah, that's regular water. This actually is not water. This is liquid methane, which you guys told me is CH4. And ethane is 2 carbons, so it's C2H6 actually. So that's all kind of cool. Now, I don't know the details, but if you're like me, these kind of insets right here are photos that were taken by the spacecraft that landed on Titan. And I'd be like, well, how come it stopped transmitting? I think that's interesting. It ran out of power, the aliens go shut it off, did it. So, that is cool. So here are some medium-sized moons around Saturn. So which one looks like the Death Star, guys?
Mimas.
Yes, Mimas. Isn't that cool? I just think that is so cool. And if you study kind of for Saturn, Saturn's got the most beautiful rings. But did you catch, I like what the video showed you, that sometimes the rings are kind of tipped so you see them, but sometimes they're kind of what we call edge on, and you can't really see the rings of Saturn. So at the observatory, when we're trying to kind of tell people looking through the telescopes, we kind of warn them whether, yeah, you can see the rings or no, you can't. So, pretty cool. So, Enceladus, and these are the geysers coming off. So cool. Well, how close are we?
Couple more pages.
Okay.
There's 3 more slides, but 2 more slides of notes.
Thank you. That helps. Well, let's go ahead. I'll put this up here, but this is where we're going to start on Wednesday. Oops, sorry. So this is where we're going to start on Wednesday. Go back. Go forward. Okay. So Wednesday, what I see it is, I don't have a lot of lecture to do. Wednesday, one of the things I do want to do is take a look at another constellation. Yay. So we'll do that Wednesday, and I'll give out the sky maps for March, because you might want to use them for your your own labs. So we'll see you on Wednesday. Remember, the review session is before class, though. Or it will be recorded.